All right, our next speaker is Toon Smeele with Utrecht University, and his talk is entitled Exploring the iRODS Native Protocol, a Hidden Gem.
Well, I hope you're all back from lunch or surviving your evening if you're in another continent, or maybe even the morning. But anyway, yes, so what is the native protocol? It's what this is all about. And if I can pass on to the next sheet here. Yeah, there we are. So a small agenda, first get you the context of the iRODS protocol, and then we'll look at some design and implementation of a native protocol, do a little bit of a performance benchmark and summarize. Now this will be like, very much like a summary. If you want to have some more in-depth technical information, then look out for the proceedings. There will be a paper in there. So the iRODS protocol is actually pretty old. It was developed back in 1986. I hope you all were born at that point in time, but if not, it's that old. It's amazing. It's still operational, but it originates from that time. And it originally was used to exchange SQL, like you now would do with a Postgres database. Well, in that time it was used for ingress as a starter. So the developer of that protocol for ingress, one of the persons there was Michael Wen. And as he was asked to cooperate with the storage resource broker, which is the predecessor to iRODS, he modified that protocol to cater for more complex data structures to be exchanged, more complex than the SQL data structures. And it had to be a distributed client-server protocol, so it would work in a data grid. So you can imagine that is all quite complicated stuff. And therefore, it's amazing that this is still operational, it's flexible, it's efficient, it's still there, and you're using it. So I think when Corey presented the iRODS foyer, you could also see how this is client-server. It does a RODS connect call, it receives back something, and then it starts exchange API calls, and the end is a disconnect. So it's really standard client-server kind of things. You can also see that the client takes, priority here. He takes the initiative. Now, does this log entry look familiar to you? I'm sure some of you have come across this log entry, right? And it's kind of a cryptic thing. It says, read 0 expected 4. Wonder where that came from? Well, it has to do with the common data packet structure of iRODS. So any packet any message that is being sent across the line has the common structure. It starts with an indication of its length, which is the 4 bytes. And if there's no message, hey, the server expected 4 bytes is not there, right? So then you have to, that's where the 4 bytes on the left side, the missing 4 bytes originates from. But actually the buildup of a message is all common. First a header, then the actual message, potentially an error message, and lastly a byte stream. For instance, the content of a replica. All of these components can be length 0 if they are absent or otherwise filled. But the nice part are the dark green parts, because they are actually data structures. And they are C-structs serialized in a way that they can be composed, but they're really, integers, characters, strings, doubles, the common stuff you find across languages. They are composed and they are being given well-known names, like here's an actual one, jQuery out, PI, which is a name of a C structure that is being exchanged between the client and the iRODS server. And because they are known at both sides, that saves a tremendous amount of information that needs to be sent across, because you know the structure, what you're going to accept or have sent. So you don't have to convey information over that structure. The only downside is that it requires compatible releases. So you may have come across where you have versions of a client and a server that were out of sync, and then that client may send messages to the server if it's a higher release than the server that the server would not comprehend. That makes sense. So the Exchange data structure is serialized, but there's actually not just one way of doing that. Originally, there was the native protocol serialization, which was a binary, dense, efficient way of communicating information. It is implemented in the iRODS client library available for C, C++ clients. But then there was this notion of other languages like Java, Python, and the likes that also needed to be able to access iRODS. And to simplify matters for them, without creating a client library, a tagged string version with XML-like syntaxes was devised, and that's actually being used by all the non-C clients. So far, I haven't come across any other client that's not C that's not using this one. So actually, that native protocol is hardly used. It's used by the I commands. It's used by Kanki, some of these clients, but they have to be C-based. Now, the benefit of that is that it could reuse the XML parsing libraries, of course, but the downside is the native protocol got hidden away. So I thought, how hard is it to implement this native protocol in a different language? Is it that hard, or can we do it? Well, this is how you could do it. So I design and implement what I call a iRODS prototype library, this time in Java. And actually it's a layered protocol. So on the bottom layer, the fundament is you need to have a TCP session between the client and the server. So maintain that session, do security stuff on that if you need to, and exchange messages, serialized messages, because this is what the native protocol and the XML protocol do. They serialize the C structures, data types before they send it across. So that next layer is the message serialization. And on top of that, you want to control how, which messages are being exchanged, so that's the actual client API that you would implement. There is where I had to implement, this transformation between the iRODS data structures and actually data structures that are common within a certain language. Like in Java, you have, of course, the Java classes. So you would like to have, types that are close to Java. Total effort, interesting. After 60 hours, there was a prototype and a design and prototype, and some 4 additional weeks were required to complete it all. I have this basic functionality going. And in fact, I needed to do a lot of investigation, reverse engineering, look into the iRODS source code, because that's where the API calls are documented, which makes sense because that's where the source code is. So that's good, but it does require you to get an in-depth understanding, and that was a major part of that time. So it's actually not that bad. And my conclusion would be, we could re-implement the native protocol in many different languages without too much effort. So it's perfectly doable. Now, is it worthwhile? So let's benchmark these two together. So actually my implementation would give you the choice, because as you interact with iRODS, the client will, in its first messages, will indicate, I want to use the native protocol, or I want to use the XML protocol for a variant. So by tweaking that and supporting both, you can benchmark actually what the savings are if you do one or the other. The benchmark consists of an authentication session. So authenticate natively with iRODS, then stat a data object, see if you can get some statistics, do a general query, very common of course within iRODS. There's many queries being done all the time, and then actually download some replica content. And as you can imagine, I got very enthusiastic about the native protocol because it packs data much smaller than the XML protocol, really much smaller. And let's have a look at it. But the most striking example is the general query, because it gets better as you pack more complex data structures and serialize them and get them across. So in terms of jQuery, you see that the headers components are almost the same. There's hardly any gain because the headers are always XML formatted, so that regardless of the protocol used. But then the message itself, you can gain, the native protocol will pack it into 28% of the size that the XML protocol will do. That's a lot. It's like, the XML takes 4 times more space. So is this true only for jQuery? Well, no. I mean, if you look at other things, like I was expecting that the equivalent of, get the content of a replica wouldn't make much change, because that's, you have to get the actual bytes across, and that's the last part of the component. It's already binary coded, so what would you gain? Still, if you have to open the replica, you have to close the replica, so there's multiple API calls involved. And actually you see that some of those API calls also, you would gain like 50%. So this is quite dramatic. I mean, even sending data objects across, the replica content across is a significant thing. So there was this prototype library, and we had plans to migrate our data to Serve, as Serve was doing the hosting, like was being told by Surgeon already. So I created a small application I pumped based on this library to actually put it to use and copy data objects across. And I mean, we run it in a tmux session, it's great. I mean, it feels like you're in a racing car compared to doing other things. So iRODS can be extremely fast. It's just that, things surrounding iRODS can take back some of the performance and store it there. Apart from the API library, it was useful to create a couple of macro functions. For instance, authentication is a couple of API calls traditionally. So if you glue them together, do them in the macro, then you don't have to program it ever so often. And there were some other macros as well. My summary is native will save you in network bandwidth, a lot of network bandwidth if you use it, compared to the XML variant. So let's do the native. Let's get more native in here. It really deserves more language binding besides C and C++. So I'm challenging Corey to do one in iRODS4j. But also I think the PRC client, would benefit greatly from having a native binding. And I think, I have shared my source code, so you can look for, how that design is done and implement it with similar approaches. Powerful, highly efficient, recommended. Thank you so much.
All right, do we have any questions for Ton? I would be interested in seeing how your implementation performs against the actual C application for iRODS that is doing the same work, just to compare like what is the actual performance difference between, I guess at this point, Java versus C and C++, right? I would imagine they're pretty close at this point, depending on like if you let the JVM run.
Yeah, what I would expect is that actually the network overhead, would surpass any differences in those two languages. Because if you look at the execution models of Java and C in general, they are like a factor, the same or up to a factor 3, which is close enough. So Java is pretty fast still, although it's being interpreted on a certain level. So probably the network itself could be, the round trips of the API calls could be the limiting factor rather than the processing on server and client side.
And there might be room for like, what is it, JVM tuning, which I'm not great at understanding myself, so.
Yeah, I mean, it can be done, yeah. Yeah, it'd be cool to compare that, I agree.
Okay.
Thank you, yes. Other questions? Yeah.
Other questions? Yeah.
Does iPump do everything that you want it to do? Is there anything left to poke at? Or have you basically covered enough to know what we know?
Yeah, well, the first one was, non-federated zones to pump data across, to do the data objects, and then make sure that the original creator comes up at the same creator at the target if that user exists over there. So there's some smart things in there to keep some provenance information. But it was lacking empty collection copying over, and also AVU copying over. So that was the first. So I'm now creating the second one, which I hope to complete after this conference in about a week, doing that part as well, and also doing data objects in parallel. Since we commonly find we have a few like large data objects, they could be terabytes even, but most of the users have like more like in the megabytes, gigabyte kind of data objects. So if you can do them in parallel, just independently, that will save a lot of time. So that's that implementation. I will use a scheduler to fan it out over multiple threads. It's almost done, but needs another week. So don't look at the iPump repository yet, guys. It's still a bit messy, but there will be a new version in a week or so. Thank you.
Do you intend to package the XML, the packing instruction logic or implementation into a separate dependency? That way, if it's packaged, then that means it would make it easier for iRODS, for J and other implementations to adopt what you've already spent time implementing.
Yeah, it is. So apart from the macros, you mean? Yeah. So it's already largely independent. So I originally had iPump in there as well. I pulled it out so to make it the iRODS library sort of the complete library. It does have the macros, and I found that to be quite useful. For instance, if you want to do a query, then to make sure that you close the query in the proper fashion, that's hard for users in terms of doing the right API calls. So if there's a macro doing that, I created an iterator for it, which automatically closes the query at the right time, and you can cancel the query halfway if you want to, and the likes. That makes sense. So those kind of macros, yeah, but that's not much. I mean, it's just easing the things up a bit. Mm-hmm. But then, I haven't got any serious plans to release the code beyond this, to be honest, because if you release it, you make the effort to maintain it. But hopefully the ideas can find their ways into other code stacks.
Okay.
Yeah.
Oh, we got a question in the back.
Yeah, so the data structures that you're transporting, from what I recall vaguely, were defined with macro magic within the server side of things. So did you just sort of inspect the code and copy those into plain old Java objects, or is there tighter integration with the server repo also?
Well, actually, I used a composite design template, so to create like the base data types, and then to compose them into any variable structure. So in that composition, there's some compositions that have been named, and sometimes I created classes for them, but mainly I created an engine so that any of those compositions could be taken care of. If there is a packing instruction, which is the definition of such a structure, basically.
Right, yeah. Mm-hmm.
So that definition would then drive how you would parse it. So there's a parsing engine in it for that. Yeah, so that's in, if we look back at the,
I mean, ultimately, what I'm wondering
here,
is,
the jQuery out
Yeah.
API. So there are certain definitions which will, for the people that will state actually the specification of such a structure. And you can use that definition to parse anything that you receive in a proper fashion.
all right, makes sense, thanks.
All right, thank you.
You're welcome.